Okay, so what we have here, again, is pseudocode for our KNN algorithm. And I'm sort of writing it as like a function. So you're going to be given some training data D. So that's the little XY points, XY1, XY2, XY3, so on and so forth. You're given some kind of distance metric or similarity function. And this is important because this represents our domain knowledge, as I think we've already said. You get some number of neighbors that you care about, K, hence the KNN, which also, by the way, represents domain knowledge. Tells you something about how many neighbors you think you should have. And then you're given some particular new query point, and I want to output some kind of answer, some label, some value. So the KNN algorithm is remarkably simple. Given these things, you simply find a set of nearest neighbors such that they are the K closest to your query point.
Okay, I'm sort of processing this. So the data, the capital D, are those pairs, and there's a set of pairs?
Yes.
Okay. And K smallest distances. So this NN, this is a set?
Yes.
And it consists of all the elements in the data that are closest to the query point.
Yep.
And so the query point is a parameter of that. Okay, yeah, all right. I think. And then it says just return.
Yeah, so we haven't figured out what to return. So there's two separate cases we've been talking about so far. One is where we're doing classification, and one is where we're doing regression. So a question for you would be, what do you think we should do when we're doing classification, sort of what we were doing before on the map? What would be a way of returning a proper label?
So you want a label, not like a weight on a label or something like that?
No, I want a label. You have to produce an answer. You have to commit to something, Michael.
All right. Can I commit to more than one thing?
Nope.
Okay. So I would say that a reasonable thing to do there would be, we have the Y's associated with the things in NN.
Yep.
So I would go with they should vote.
Ah, I like that. I think that's a good one. So we'll simply vote. And what does it mean to vote?
It means, let's see, so I feel like there would be a way to represent it in terms of NN, the set. Like, do you want me to write it formally?
No.
Oh. Then I would just say the closest points, whichever YI is most frequent among the closest points wins.
Yeah, right. So you want to find a vote of, basically a vote of the YIs that are part of the neighborhood set. And you take the plurality.
Ah, plurality, I see. So it's whichever one occurs the most.
Right. It's the
what
mode.
If there's ties? The mode, right. A la mode.
What if there are ties? That's a good point. Well, if there are ties among the output, then you're just going to have to pick one.
Okay.
And there's lots of ways you might do that. You might say, well, I'll take the one that is, say, most commonly represented in the data, period. Or I'll just randomly pick each time. Or any number of ways you can imagine doing that.
The one that's first alphabetically.
The one that's first lexicographically. Okay, what about in the regression case?
Okay, so in the regression case, our YIs are numbers.
Mm-hmm.
And we have the closest YIs, so we have a bunch of those numbers. And it seems like if you have a pile of numbers and have to return one, a standard thing to do would be to take the average or the mean.
Yeah. So let's just simply take the mean of the YIs. And at least there you don't have to worry about a tie.
That's right. Though I guess, we didn't really deal with the question of what happens if there's more than K smallest. Like, what if they're all exactly the same distance? All N of them are exactly the same distance. So which are the K closest?
Well, there's lots of things you could do there. I guess what I would suggest doing is take the if you have more than K that are closest because you have a bunch of ties in terms of the distance, just take all of them. Get the smallest number greater than or equal to K.
Okay.
Does that seem reasonable?
Yeah, I think that's what college rankings do.
Actually, that is what college rankings do. And then that's exactly what college rankings do. So let's do that. We know that college rankings make sense.
Yeah, they're scientifically proven to be
used
scary to people in colleges.
That's exactly right. So here's what we got, Michael. So all we do is we take the training data. We have some notion of similarity or distance. We have a notion of the number of neighbors that we care about. We have a query point. We find the K closest ones, breaking ties accordingly. And then we basically average in some way, in a way that makes sense for classification, a way that makes sense for regression, and we're done. It's a very simple algorithm. But some of that's because a lot of decisions are being left up to the designer. The distance metric, the number K, how you're going to break ties, exactly how you choose to implement voting, exactly how you choose to implement the mean or the average operation that you chose to do here. And you could put a bunch of different things here, and you end up you could end up with completely different answers.
Mm.
By the way, one thing that you might do, just to give you an example of just how much range there is here, is rather than doing a simple vote by counting, you could do a vote that is, say, weighted by how far away you are. So we could have a weighted vote.
Oh,
That might help us with ties.
that could help with ties. Yeah.
You could do a weighted average.
Yes. Right. So you're basically saying that the y values that correspond to x values that are closer to the query point have more of an influence on the mean.
Which makes some sense, right?
No, I think it makes a lot of sense.
So how would you weight that, by the way? What would you do?
I'd weight it by the similarity.
Right. So, well, in this case, the similarity is we have a distance, not a similarity. So you'd have to, weight it by something like 1 over the distance.
Oh, I see. Okay. That seems like a hack.
Sure, but it's a hack that sort of makes sense.
Okay.
Okay. So anyway, simple algorithm, lots and lots of decisions to make here, all of which could, in principle, have a pretty big effect. And so in order to see that, I want to do 2 quizzes that I hope get to the heart of this and maybe give us a little bit of insight into how some of these decisions might matter on the one hand, and exactly just how simple or not simple this algorithm turns out to be. Okay?
Awesome.